We are talking about slope and writing and graphing linear functions, and we want to be able to find the slope of a line given a graph or 2 points on a line. So slope-intercept form of a line, we have y equals mx plus b, where y and x, those are a coordinate point. Where we have x is the input and y is the output. We also have the slope, which is m, and then we have the y-intercept, which is b. And in the y-intercept, we know that the x value is always 0, and the y coordinate is always some b value, wherever it crosses the y-axis. So to calculate the slope of a line using a graph, we want to do slope equals rise over run, or slope equals the change in y over the change in x. Another way that we can say that is, we could say that as delta y over delta x. And delta just means change. So if we look at this graph over here, we want to be able to find out the rise over the run. And so basically for this one, we're able to just count what the count the grid marks, because we have 2 points that are located directly on the grid. So I'm just going to draw a vertical line going down from this point. So we're going down, so this is going to be -9 in the y direction. And in the x direction, this one's going to be +8 because we're going to the right, so we're adding 8. So if we were going to calculate the slope from these points right here, all we do is we put the rise over the run. So the rise in this case is -9, and the run is 8. So that would be our slope from the graph. So that's equal to m. So that's how we can calculate the slope, or if we are given a graph and we're able to just count that way. Another way that we can calculate the slope is if we're given, so here we have the point, well, we should label our grid here, 1, 2, 3, 4, 5. So that's +5, 1, 2, 3, 4, 5. That's -5, 2, 3, 4, 5. That's -5, 1, 2, 3, 4, 5. That's +5 right there. So up here we have the coordinate point of -7 7. And over here, we have the coordinate point of 1, -2. And so we can use our slope formula where we have y2 minus y1 over x2 minus x1 is equal to slope. So it actually doesn't matter which one we call x1 and which one we call y1. The only thing that matters is that we have the points stacked vertically over top of one another. So we have two coordinates. We have the coordinate of 1, -2, and we have the coordinate of -7, 7. So we could call them x1, y1, but the important thing is that we just know that x and y and x and y. And we'll show two examples of why it'll always be the same. So just as a side note, whenever I'm calculating slope, I always just start this way. So whenever I'm calculating slope, I always start with this. M equals, I put a big division sign and a minus and a minus. So whenever I'm calculating slope, I don't even worry about x and y. I just make sure I put these minuses and I have the division there. So then when I'm calculating the slope, we can substitute the values in. So I start, the slope is equal to, and now I substitute the values in. It doesn't matter which one's x1 or y1 as long as we have the points stacked vertically. So it should be -2 over 1. And then the y value is 7 over -7. So in the numerator, we end up with -2 minus 7, which is -9. And then in the denominator, we have 1 minus a -7, which is actually, remember, if we have negative in a row, we actually add that. So that ends up to be 8. So here we have -9 over 8. Here we have -9 over 8. So those are both the same slope. And then I told you earlier that it doesn't matter which one comes first, and it doesn't matter. So we'll go ahead and do find the slope starting with the other point first. So that becomes 7 over -7, and then -2 over 1. And negative and a negative means that we add. So that becomes 9. And -7 minus 1, that becomes -8. So again, we have 9 over 8. So both slopes are the same.